Hello, good morning or good afternoon. Today we're gonna talk about our topic that is the biosensors for detecting pathogens in food. My name is Felipe El Chapa of the group 441. Okay, in our first slide we have the background of or the context about this topic. That is the fodder diseases kills a million pollinations every year. Because of this rapid detection of pathogens has become essential to prevent our breaks. There's also growing demand for diagnostics, the tools that are referral proper and low cost, especially in the food industry, and that is very important. Okay, in our next slide, we have the importance of the topic. Why we decided to choose this? Well, the food safety is a global concern. Pathogens, for example, the E. coli, the Salmonella, and the Listeria, pose a constant threat to public health. Detecting these microorganisms quality can help to reduce the contamination and prevent problem diseases. Okay, now what were the limitations of these traditional methods that we know? Well, the traditional microbiologic methods are currently and very slow. They require especially laboratory, ternary person, and money. Because of this, they are not so rapid or distant detections and increase the risk of the contamination spreading. Now, okay, we talk about this topic and maybe you are asking, what is a biosensor? Well, a biosensor is the device to combine a biological component with a technological element. It combines a biological interaction into measurable signals, and this allows for rapid, sensitive, and specific detection of pathogens in the food, in this case. Now, we have the basic components of biosensor because, of course, every biosensor have different kind of components, but in this case, we have three. The first one is the biological element. For example, enzymes, antibiotics, DNA, or cells. The next one is a traducer, with the biosensor needs a traducer. In this case, which it converts to biological interactions into electric or optical signals. And the last one is a read system, which interprets the displays of the signal. Now, we have the classification of biosensors. Biosensors can be classified by series of the biocreations elements or by the traduction method that they use. The most common types are electromagneticals, optical, ceilotropic, and the biosensors. Now, in this case, we have the first one. We're gonna mention every kind of biosensor. The first one is the electromechanical biosensor. This one is a biosensor making electric signals to produce when the pathogens interacting with the air recognition elements, and they are often used to detect E. coli in the meat. These advantages include high sensitivity, low cost, and easy manipulation. However, they require careful sample preparation or frequent calibration. They can be a little bit complicated to detect the calibration because this biosensor is like very quality maybe. And yes.
Hi, I am Annabelle and I'm gonna talk about the limitations of electrochemical biosensors. Despite of their benefits, these sensors can be affected by impurities of interfering substances. They also need regular calibration to maintain accuracy and may require controlled sample preparation. On the next slide, we analyze another type of biosensor, in this case the optical biosensor. Optical biosensors detect changes in light, such as fluorescence, absorbance, or surface plasmon resonance. They are used, for example, to detect salmonella in poultry, and these biosensors offer high specificity and real-time monitoring. Now we analyze the drawbacks of optical biosensors. Their main disadvantages include the need of expensive equipment and high sensitivity to environmental conditions. They also require controlled settings to ensure accurate measurements. Now I'm gonna talk about another type of biosensor, in this case the piezoelectric biosensor. This biosensor measures changes in mass of a surface of a quartz crystal. They are commonly used to detect Listeria monocytogenes in dairy products, and these sensors allow label-free detection and real-time analysis. But in the next slide, we will analyze the limitations of this type of biosensors. These sensors can be affected by non-specific binding and sample impurities that may interfere with accuracy. Because of this, they need clean and stable samples. The last biosensor that we are going to analyze is the thermal. This type of biosensor detects heat changes produced during biochemical reactions. Many are enzyme-based and monitor the metabolic activity of pathogens. They have a simple design and stable operation, although they tend to be less sensitive than other biosensor types. And for the conclusion, biosensors are transforming the detection of pathogens in food. They address the limitation of traditional methods by providing fast, sensitive, and portable solutions. By integrating biology, nanotechnology, and engineering, biosensors significantly improve food safety and protect public health worldwide. And this is our PIA number 3. Thank you for watching.